In this lesson, we're going to learn to solve trigonometric equations, and these are just equations that have one or more trigonometric functions. In our directions, it says solve each equation over the interval 0 to 2 pi. So this is an indication that our answers should be in radian measure. Notice that the bracket on 0 indicates that 0 can be part of our solution set, but the parentheses on 2 pi means that 2 pi cannot. And this is just because these are coterminal angles. Looking at our first example, we have tangent theta minus 1 equals 0. In order to solve this, we first get tangent theta by itself. So we're going to add the 1 to both sides. And now we're going to use the knowledge that tangent theta is calculated by sine theta over cosine theta, or y over x. So tangent is positive in quadrants 1 and 3. So looking in quadrant 1, I see that at pi over 4, I have the ordered pair root 2 over 2, root 2 over 2. So if I do y over x, I'm going to get a positive 1. In quadrant 3, I see that at 5 pi over 4, negative root 2 over 2 divided by negative root 2 over 2 would give me a positive 1. So these two angles are my solution. Now, it makes sense that both of these would be over 4 because every angle in the pi over 4 family has a root 2 over 2 in the x position and a root 2 over 2 in the y position. They just change signs depending on what quadrant they're in. So this makes sense. In our next problem, we have a reciprocal function. So we're looking at root 3 cosecant theta plus 2 equals 0. So first we want to solve for cosecant theta. So we subtract 2 and divide by root 3 to get cosecant theta is negative 2 over root 3. But we know that cosecant theta is the reciprocal of sine theta. So that means that sine theta is negative root 3 over 2. So we're looking for angles that have a y value of negative root 3 over 2 between 0 and 2 pi. So sine is positive in quadrants 1 and 2, so I shouldn't be able to find an answer there. But as I move into quadrant 3, I see that my y values become negative. And at 4 pi over 3 in particular, I've got a y value of negative root 3 over 2. So 4 pi over 3 is a solution to this problem. Sine is also negative in quadrant 4. And I see that at 5 pi over 3, I have a negative root 3 over 2 in the y position. So those are my solutions. In the next problem, I have sine x plus 1 times 2 cosine x minus 1 equals 0. So for this, I've got a factor times a factor equals 0. So this can be solved using the zero product property by setting each of those equal to 0. So sine x plus 1 is 0, and 2 cosine x minus 1 is 0. So let's start with our first equation. We're going to solve for sine x, and we get that sine x is negative 1. So I want to know all the angles between 0 all the way around to 2 pi that have a y value of negative 1. And the only one that has that particular y value is 3 pi over 2. So this is a trig equation that has one solution. So now we move to our next trig equation. We're going to solve 2 cosine x minus 1 equals 0. So our first step is to get cosine x by itself. So we add the 1, divide by 2. So I want to know where cosine x is positive 1/2. So I know that cosine is positive in quadrants 1 and 4. So that's where my answer should come from. So when I look in quadrant 1, I see that pi over 6 has root 3 over 2, not what I need. Pi over 4 has root 2 over 2, not so much. Pi over 3, however, has a 1/2 in the x position, so that is one of my solutions. So it makes sense that my next solution should also be in the pi over 3 family. And because cosine is positive in 1 and 4, 5 pi over 3 we see has the 1/2 in the x position as well. So pi over 3 and 5 pi over 3 are the solutions to 2 cosine x minus 1 equals 0, which means that this total problem has 3 solutions. Now, looking at 2 cosine squared theta plus root 3 cosine theta equals 0. The first thing I notice here is that each of our terms have a cosine theta in common. So that's a like term. So we can factor that term out, giving us cosine theta times 2 cosine theta plus root 3 equals 0. And so now we can use the zero product property to solve. So one equation is cosine theta equals 0. So I want to know what angles, starting at 0, wrapping around to 2 pi, have an x value or a cosine value of 0. So the first place I see that happen is at pi over 2. The next place is at 3 pi over 2. So pi over 2 and 3 pi over 2 are our solutions there. Moving to our next equation, I'm going to solve 2 cosine theta plus root 3 equals 0 for cosine theta. So I get that cosine theta is negative root 3 over 2. So I subtracted root 3 and divided by 2 to get that. Now cosine is negative in quadrants 2 and 3. So that's where my answer should come from. So looking in quadrant 2, I want to know which of these angles have a x value of negative root 3 over 2. And I see that that happens right here at 5 pi over 6. Moving to quadrant 3, I see that 7 pi over 6 also has that x value. So those are my solutions to that equation. So this particular problem has 4 solutions: pi over 2, 3 pi over 2, 5 pi over 6, and 7 pi over 6. Our next equation, tangent squared theta equals 1/3. Now, to solve this, we're going to need to use the square root method. Now, we have to be very careful here, because when I take the square root of a number, I get a positive number. So the square root of 1/3 is positive 1 over root 3. However, what I'm really asking is what can I square to get 1/3? And that could be a positive or a negative number. So putting this plus or minus is absolutely crucial to having a successful problem. Now, when you take the square root of a fraction, you take the square root of the numerator and the denominator. So we actually get that tangent theta is plus or minus 1 over root 3, which leads to 2 equations. Tangent theta equals positive 1 over root 3, and tangent theta equals negative 1 over root 3. So, starting with our positive 1 over root 3, I know that tangent is positive in quadrants 1 and 3. So starting in 1, I see that at pi over 6, if I did 1/2 divided by root 3 over 2, then I've got 1 over root 3. So pi over 6 is definitely a solution. Now, because pi over 6 is a solution, when I look in quadrant 3, I'm first going to look at 7 pi over 6. And I see that negative 1/2 over negative root 3 over 2 will give me 1 over root 3. Now, tangent theta equals negative 1 over root 3. Well, that's going to happen in quadrants 2 and 4. So if I look at 5 pi over 6, 1 over negative root 3 gives me the desired negative 1 over root 3. And at 11 pi over 6, I also get negative 1 over root 3. So the really neat thing about this particular problem is that my solution is the entire pi over 6 family between 0 and 2 pi. Now, at first glance, this next problem looks really different than things that we've done before. We have sine beta equals root 3 cosine beta. To do this, we're going to have to use trigonometric identities. So if we think this through, what would happen if we divide both sides by cosine beta? Well, we see that on the left side, sine beta over cosine beta is a trig identity. It's actually tangent beta. On the right side, the cosine betas will cancel, leaving us with root 3. So using this trigonometric identity, we've now reduced this to a simpler problem where we just look for y over x, or sine over cosine, to get a positive root 3. So the answer must come from quadrants 1 and 3 because that's where tangent is positive. So we see that at pi over 6, I have 1 over root 3. So that is the opposite of what I want. So that cannot be a solution. At pi over 4, I've got root 2 over root 2. That's a positive 1. That is not what I'm looking for. Root 3 over 1 gives me root 3. So pi over 3 is one of my solutions. So when I look in quadrant 3, I'm going to look at the pi over 3 angle first. So that's 4 pi over 3. And I see that negative root 3 over negative 1 gives me 4 pi over 3. So those are my solutions.